back to my YouTube channel. If you come across this question in your forthcoming exams, this is how you are going to solve it. Let's go. A solid cube of aluminium is 1.5 centimeters on each edge. The density of aluminium is 2,700 kilogram per meter cube. Find the mass of the cube. And we are given option A to be 7.5 grams, option B to be 9.1 grams, option C to be 12.0 grams, and option D to be 15.0 grams. Now, looking at this question, the first thing that will come to your mind is this. They are asked to find what? The mass. But there's a relationship between the mass and density because density is mass per unit volume. Okay? Now, we say that density is equals to mass over volume. But we are given a cube and they gave us a side of a cube which is 1.5 centimeters. Now, the length of the cube, which is the side of the cube, is 1.5 centimeters. But we don't have the volume. Now, we need to get the volume before we can think of getting the mass. Now, the volume is L cube because all the sides are equal. So we are going to say 1.5 raised to the power of what? 3. And it's going to give us 3.375 centimeter cube. That is just our length. Okay? But density in the question is given as 2,700 kilogram per meter cube. Now, look at the units. The unit of volume is centimeter cube, but the unit of density is kilogram per meter cube. We cannot solve for mass if the units are not the same. So what you are going to do now is to convert this centimeter cube to meter cube before we think of what? Solving for our mass. So how do we do that? We are going to divide this value by 1 million because if you want to convert centimeter to meter, you divide by what? 100. You divide by 100, right? But here we have centimeter cube. So I'm going to divide by 100 into 3. That is 1 million. So my volume is equal to 3.375 divided by 1 million. Okay? Now it's going to give me 3.approximately 4 times 10 raised to power what? Minus 6 meter cube. I hope that is clear. Now, if you have gotten that, the next thing we are going to do is to find our mass. Now, remembering that density is equal to mass over volume. Okay? Now, saying cross multiply, our mass is equal to density what? Volume. So let's work it out. M is equal to what's my density? 2,700 times 3.4 times 10 raised to power minus what? 6. Okay? Then by the time you multiply it, you are going to get what? 0.0091 kilograms. You are going to get 0.0091 kilograms. Okay? But looking at the options we have provided, the answer is given in terms of grams. So even though we have kilograms, you need to do what? Convert it to grams simply by multiplying by 1,000. So M is equal to 0.0091 multiplied by 1,000, okay? Which will give me to be 9.1 grams. I hope that is clear. And from what we have gotten so far, the correct option to this question is option B. Calculate the up thrust on a spherical ball of volume 4.2 times 10 to the power of minus 4 meter cube when totally immersed in a liquid of density 1,028 kilogram per meter cube. Okay? Then we are given G to be 10 meters per second square. Option A is 5.2 Newton, option B is 4.3 Newton, option C is 3.0 Newton, and option D 2.4 Newton. Looking at this question, we must remember that what is up thrust? Up thrust is that upward force that acts on any object that is partially or totally immersed in a fluid. Partially means 1/3 or 1/4 of the object is immersed in a fluid. Totally means the whole of the body is inside the fluid, that is wholly immersed in a fluid, okay? But in this question, they said the body was totally immersed in a fluid. Now, let's look at the parameters we have, okay? We are given the volume to be 4.2 times 10 to the power of minus 4 meter cube, okay? We are given the density to be 1028 kilogram per meter cube, and we are given G to be 10 meters per second square, right? You must also remember that according to Archimedes' principle, that the upthrust is equal to the weight of the fluid displaced, right? Now the upthrust U is equals to the volume, because it's totally immersed in a fluid, multiply by density multiply by G, which is gravity, okay? Then let's substitute into what we have. We have that what volume is 4.2 multiplied by 10 power minus 4 times 1028 times what? 10. Are we there? Now by the time we multiply all through, our answer is going to give us 4.32 Newton, right? Then if you are using approximate value, you're going to, because this 2 is not up to 5, you're just going to use 4.3 Newton, right? And from what we have so far, the correct option to this question is option B. A uniform meter rule AB balanced on a knife edge 60 centimeters from end B when a load of 22 grams is kept 10 centimeters away from end A. What is the weight of the meter rule? Option A is 40 grams, option B is 55 grams, option C is 66 grams, and option D is 37 grams. For us to solve this question, one thing will come to our mind: a meter rule. A meter rule ranges from 0 to 100. That means we are going to draw with a meter rule. This is point A, and this is point what? B. Now this one is what? Ranges from 0 to 100 centimeter. Alright, so let's go again. It is balanced on a knife edge 60 cm from end B. This is end B, right? 60 cm from here means it's going to be balanced at what? At 40. So let's place the knife edge at 40 cm. Okay, so that the distance between this and this is going to give us what? 60. That is what they mean by that. Now, when a load of 22 grams is kept 10 cm away from end A, C and A, okay, then you have 10 cm here, a load of what? 22 grams. What are we looking for? What is the weight of the meter rule? Now, the weight of the meter is going to be placed at the rightful center. If this meter rule is from 0 to 100, the center will be what? The center of gravity will be at 50. And that is where we're going to put the weight of the meter rule, right? Okay, so we're going to place it at rightful center, which is what? 50 centimeters, right? Now we go down. You're looking for what? The mass. So what do? We say clockwise moment equals anti-clockwise. This is clockwise moment, while this is anti-clockwise moment. Okay, now this is the mass multiplied by distance between here and here is what? 10 cm. Distance between here and here is what? 30 cm. You know the moment is the force multiplied by perpendicular what? Distance. You are comparing from here to what? To the center of the pivot. So the difference between them is what? 10. So let's solve by saying that clockwise moment is equals to anti-clockwise moment. My clockwise moment is m multiplied by the distance is what? 10. So this is m times 10, then is equals to, my anti-clockwise is 22 multiplied by 30. This is 22 multiplied by 30, right? Because you're looking for the weight or the mass of the meter rule, divide both sides by the coefficient, which is what? 10. Now this cancel this, we have what? Mass, right? Now 0 cancels what? 0. So we have 22 multiplied by 3 is going to give us 66 grams. I hope that is clear. Now the correct option from what we have gotten so far is option C. Find the tension T1 in the diagram below if the system is in equilibrium and we are given G as 10 meters per second square. Now look at the diagram. We are given this diagram. This is T1 going this direction. This is a mass of 10 kilogram going down. Then another tension of T2 acting this direction. This tension T2 is inclined at an angle 30 degrees with the vertical. Okay, so the first thing we are going to do is to resolve it to be able to know how to get our tension T1. Now the options we have: A, 200 over root 3 Newton. Option B is 100 over root 3 Newton. Option C is 300 over root 3 Newton and 100 Newton. So let's solve this question. The first thing that will come to our mind is this: the principle of triangle of forces, which states that if three forces are in equilibrium, they must be represented in both magnitude and direction by the three sides of a triangle taken in order. So using that principle, now that is principle of triangle of forces, we are going to use it to resolve this vector on the board. So what do we have? We have the 10 kilogram acting downwards. And remember, this is supposed to be a force, okay? Now the first thing we are going to do is to state that the mass is what? 10 kilogram, and G is equals to 10 meters per second square. Okay, but the weight is equals to mg. So let's get the weight, which is 10 times 10 is going to give us 100 Newton, right? Let's solve. By resolving what we have the force of 100 Newton acting down. Okay, we now have this as 100 Newton. This is 100. Okay, and what again? Now we have the tension T1 acting on a horizontal direction. We have tension T1. We have this, right? Okay, now it is inclined at an angle 90 degrees with the 100 Newton, right? Now for the tension T2 is acting in this direction. That is T2, right? Okay, so it has an angle of what? 30 degrees, resulting with this 100 Newton. Now, so what do we do now? What you are going to do is to use the sine rule, okay? And sine rule states that what? T2, let me start with this one. 100 Newton over what? The angle here. But because you don't have any angle here, you have to resolve it. The sum of angles in a triangle is equals to 180. This is 90, this is 30, and this is what? 60. So here is 60 what? Degrees. Now this is 60 degrees. So what do? We say 100 over sine what? 60. Okay, then it's equals to T1 over sine 30. Then it's equals to T2 over sine 90. Okay, so because you're looking for T1, let's equate these two together. So we say 100 over sine 60 is equals to T1 over sine 30, right? We do cross multiply. We say that T1 is equals to 100 sine 30 all over sine 60, right? So we say this is 100, sine 30 is 0.5, and sine 60 is root 3 over 2, right? By the time you work it out, my T1 is going to be what? 100 over root 3 Newton. Is that clear? If you are watching this channel for the first time, please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And don't forget to share so that other students that are preparing for this forthcoming exam can watch it and learn from it. If you have any other thing you want me to do for you, if you have any question on any topic, you can drop in the comment section. I will see you next time in the next one. Bye for now.